Welcome back to the 90-Day AI Mastery course. I am thrilled you are here for day 3. Before we dive in, let me quickly recap what we have covered so far. On day 1, we set up Python, VS Code, and Git and wrote our very first Hello World program. On day 2, we explored variables and the 4 core data types: integers, floats, strings, and booleans. Today, day 3, we are going to build on that foundation and learn 2 incredibly important topics: typecasting and operators. Typecasting is how you convert a value from one data type to another, for example, turning the string 25 into the integer 25 so you can do math with it. Operators are the symbols and keywords that let you perform calculations, make comparisons, and build logical conditions. These 2 topics are the engine room of Python. Every single program you will ever write, whether it is a data science script, a machine learning model, or a web application, uses operators and typecasting constantly. By the end of this lesson, you will build a fully functional grade calculator that combines everything we cover today. It is going to be a great session, so let us get started right away. Let us start with typecasting. The word casting comes from the idea of pouring a material into a mold to change its shape. In programming, casting means taking a value that exists as one data type and converting it into a different data type. Python supports 2 kinds of typecasting, and understanding both is essential. The first kind is called implicit casting. This happens automatically without you writing any extra code. Python silently converts one type to another in the background when it needs to. For example, if you add an integer and a float together, Python automatically converts the integer to a float before doing the addition. It does this to avoid losing information. Converting an integer to a float is safe because floats can represent all integers plus decimals. Python never implicitly converts in the other direction, because that would mean losing data. The second kind is called explicit casting, and this is where you step in and manually tell Python to convert a value. You do this using built-in functions: int to convert to an integer, float to convert to a float, str to convert to a string, bool to convert to a boolean, and list or tuple to convert sequences. Explicit casting is something you will do every single day as a Python developer, especially when working with user input, file reading, API responses, and data processing for AI applications. Let us see implicit casting in action with a real code example. I have declared the variable x and assigned the integer 5 to it. Then I have declared y and assigned the float 2.0 to it. Now watch what happens when I add them together with result equals x plus y. Python needs to combine an integer and a float. It cannot just pick one type arbitrarily, so it applies a rule called type promotion or widening. It converts the integer 5 into the float 5.0, and then adds 5.0 plus 2.0 to get 7.0. When you print the result, you get 7.0, not 7. And when you check the type, Python confirms it is a float. This is implicit casting. Python made that decision for you, silently and automatically. The rule Python always follows is that it only widens types, never narrows them. It will go from integer to float, or from float to complex, but it will never automatically go from float back to integer, because that would mean losing the decimal part. This is a very sensible design decision. As a programmer, you want to be the one who decides when to lose precision, not have the language do it for you without asking. Keep this widening rule in mind. It will help you predict Python's behavior when you mix different numeric types in calculations. Now let us talk about explicit casting, starting with the 2 most commonly used functions, int and float. The int function converts a value to an integer. Look at this first example. I have a variable called age_text that holds the string 25. It looks like a number, but Python treats it as text. If you try to add 1 to it, Python will raise a type error. But if you wrap it in int, Python converts the string 25 into the actual integer 25, and now you can do math with it. This is something you will do constantly when reading user input, because the input function always returns a string. Now here is an absolutely critical thing to remember about int. When you convert a float to an integer using int, it does not round the number, it truncates it. Truncate means it simply chops off everything after the decimal point. So int of 3.99 gives you 3, not 4. It does not matter that 3.99 is almost 4, int does not care about rounding. It just throws away the decimal part entirely. If you want proper rounding, you would use the round function instead. And here is another gotcha: you cannot pass a float-formatted string directly to int. Trying int of the string 3.14 will raise a value error. You must first convert it to a float with float, and then convert that to an integer. This two-step process is something many beginners stumble on, so remember it well. Let us now look at the str and bool casting functions. The str function converts any value into its string representation. This is especially useful when you want to combine a number with text using string concatenation. For example, if you have the integer 100 in a variable called score and you try to concatenate it with the string your score : using the plus operator, Python will raise a type error because you cannot directly concatenate a string and an integer. But if you wrap score in str, it converts the integer 100 into the string 100, and then concatenation works perfectly. You will use str a lot when building formatted output and log messages. Now, the bool function deserves special attention because it introduces the concept of truthy and falsy values, which is fundamental to Python logic. In Python, every single value, not just true and false, can be evaluated as a boolean. The rule is simple: 0, empty, and none are false, and everything else is true. Specifically, the integer 0 is false, the float 0.0 is false, an empty string is false, an empty list is false, an empty dictionary is false, and the special value none is false. These are called falsy values. On the other hand, any non-zero number, whether positive or negative, is true, any non-empty string is true, and any non-empty collection is true. These are called truthy values. This truthy and falsy behavior is used constantly in Python when writing if statements, and we will see exactly how in day 4. Now let us move to arithmetic operators, the mathematical operations you can perform in Python. Python has 7 arithmetic operators, and while most of them work exactly as you would expect from school math, a few have important quirks you need to know. Addition with the plus sign, subtraction with the minus sign, and multiplication with the asterisk all work in the obvious way. No surprises there. Division, however, has a very important behavior in Python 3. The / operator always returns a float, even if the result is a whole number. So 10 divided by 2 does not give you the integer 5, it gives you the float 5.0. This is different from Python 2 and from many other languages, so be aware of it. If you need an integer result from division, you use the double /, which is called floor division. Floor division divides the numbers and then rounds down to the nearest integer. So 17 floor divided by 5 gives you 3, because 17 divided by 5 is 3.4, and rounding down gives 3. The percent sign is the modulus operator, and it gives you the remainder after division. So 17 modulus 5 is 2, because 17 equals 3 times 5 plus 2. The modulus operator is surprisingly useful, and we will see a great practical example in the next slide. Finally, the double asterisk is the exponentiation operator. It raises a number to a power. 2 to the power of 10 is 1024, which you might recognize as the number of bytes in a kilobyte. The modulus operator is one of the most practically useful operators in all of programming, and I want to give it the attention it deserves. Let us look at 2 great real-world use cases. The first is checking whether a number is even or odd. A number is even if it is perfectly divisible by 2 with no remainder. So if you take a number and compute number modulus 2, you get the remainder after dividing by 2. If that remainder is 0, the number is even. If it is 1, the number is odd. This is such a common operation in programming that you should commit it to memory. Number %2 equals 0 means even. You will use this pattern when processing lists, filtering data, alternating colors in tables, and countless other situations. The second use case is converting a raw number of seconds into a human-readable time format of hours, minutes, and seconds. This is a beautiful combination of floor division and modulus working together. Take 3,725 seconds. To find the hours, you floor divide 3,725 by 3,600, because there are 3,600 seconds in an hour, and you get 1. To find the remaining seconds after removing the hours, you compute 3725 modulus 3,600, which gives you 125. Then to find the minutes from those 125 remaining seconds, you floor divide 125 by 60 to get 2. And the remaining seconds are 125 modulus 60, which gives you 5. So 3,725 seconds equals 1 hour, 2 minutes, and 5 seconds. This exact technique is used in AI applications when working with timestamps, audio files, and video processing. Before we move on to comparison operators, we need to talk about operator precedence, the rules that determine which operations Python performs first when you have multiple operators in a single expression. You probably remember learning order of operations in school, often taught with the acronym PEMDAS or BODMAS. Python follows the same rules. Parentheses come first. Whatever is inside parentheses is evaluated before anything else. This is your most powerful tool for controlling the order of evaluation. Next comes exponentiation, the double asterisk. Then multiplication, division, floor division, and modulus are all evaluated at the same level, going from left to right. Finally, addition and subtraction are evaluated last, also from left to right. Let me give you a concrete example to make this real. The expression 2 plus 3 times 4 to the power of 2 minus 1 looks ambiguous, but Python has clear rules. First, 4 to the power of 2 is 16. Then, 3 times 16 is 48. Then, 2 plus 48 is 50. Then, 50 minus 1 is 49. So the result is 49. But if you add parentheses to group things differently, like open paren 2 plus 3 close paren times open paren 4 to the power of 2 minus 1 close paren, now you get 5 times 15, which is 75. That is a completely different answer. This is why I always recommend, when in doubt, use parentheses. They cost you nothing, make your code unambiguous, and prevent subtle bugs that are very hard to find. Now we move to comparison operators. These operators compare two values and always return a Boolean, either true or false. They are the foundation of all decision-making in your programs. Let me go through each one. The double equals sign checks if two values are equal. Note carefully, it is two equals signs, not one. One equals sign is for assignment, putting a value into a variable. Two equals signs is for comparison, asking whether two values are the same. The exclamation mark followed by an equals sign checks if two values are not equal. Less than and greater than work just as they do in mathematics. Less than or equal and greater than or equal check the inclusive boundaries. Now here is where Python shows off one of its most elegant features that most other programming languages do not have, chained comparisons. In mathematics, you can write 18 is less than or equal to age, which is less than or equal to 65 as a single expression, and it reads naturally. Python lets you do exactly the same thing in code. Writing 18 less than or equal age less than or equal 65 works perfectly in Python, and it means age is between 18 and 65, inclusive. In languages like Java or JavaScript, you would have to write age greater than or equal 18 and age less than or equal 65